Welcome everybody to the talk series of the cost action on distributed knowledge graphs in collaboration with the Semantic Web Science Association. Today we have Anupriya and Ankolekar who will talk about supporting professional information workflows with knowledge graphs. Before we start, this is the talk series on knowledge graph research. We have had a few talks already by different people. And this series will continue next month, which I will say a little at the end of this session. This whole thing is organized by the Cost Action on Distributed Knowledge Graph, which is a European research network with more than 30 countries represented. We organize workshop hackathons and scientific exchanges in form of short-term scientific mission. This whole thing will last for another year, where we will continue our work and especially also continue this talk series. My name is Tobias Käfer. I'm the chair of this action, which I lead together with Axel Polleris, Michel de Montier, Ramzi Celebi, Andreas Hart, Antoine Zimmermann, Olaf Hartig, John McCrae, Anastasia Dimou, and Stefan Vostojic. Today, we have Anupriya Ankolekar, who is a co-founder and principal scientist at ModuleQ, which is a startup focused on empowering knowledge professionals through proactive mission-critical business intelligence insights. She previously was, she has a PhD in human-computer action from Carnegie Mellon University. She was assistant professor at Karlsruhe Institute of Technology and a principal research scientist at HP Labs. The talk will be about how that whole work at ModuleQ relates to the semantic vision and knowledge graphs. And before I say too much, I want to hand over to Anupriya. I'm looking forward to your talk. And one thing, we will collect questions in the YouTube chat. And then after the talk, we will ask a selection to the speaker. So please leave your questions in the YouTube chat, which we will monitor. And with that said, without further ado, Anupriya, the stage is yours. Looking forward to your talk.
Thank you very much, Tobias. I am quite honored to be giving a talk here at the Distributed Knowledge Graphs Cost Action. As he mentioned, I'm currently co-founder and principal scientist at ModuleQ. After my PhD at Carnegie Mellon, I spent some time at AIFB. And since then, I've been pretty much in industry for the last 15 years or more, working on a range of problems around professional work. That said, you know, when you're sort of outside a community for a while, there's a chance that you're rediscovering things that are well understood, or you're preaching to the converted. But that said, I hope you'll find this application of knowledge graphs interesting and meaningful. So let's start with the article that marked, as many have called it, the birth of the semantic web. This was an article published in the Scientific American in 2001 by Tim Berners-Lee, James Handler, and Aura Lassila, who was also here as a prior speaker in this talk series. And this described an approach, actually really more of a research agenda, to enable agents to accomplish tasks on behalf of users by using information intelligently on the web. And this was what sort of spearheaded a great deal of research into building knowledge representation for the web. And when this article came out, I was a PhD student working in human-computer interaction, and I found this vision very inspiring, and it's influenced my work in many ways. In particular, I was interested in how the vision focused on a human AI system that assisted humans in doing the things that were important to them. And for those of you who haven't read this article or maybe have forgotten, the schematic on the right sort of describes what the leading scenario is about. It's essentially a brother and sister working together to identify a physical therapist for their mother and schedule sessions. And this just requires a lot of coordination, reviewing of information on the web and matching of calendars. But their work is made substantially easier by agents that are working on their behalf. They're doing the search, doing kind of appointment matching or using services to do appointment matching, and essentially taking care of a whole lot of drudgery for the users. And my particular interest here was on how the agents were getting work done for humans by invoking services. And so my focus was, my interest at that time was very much into how can agents discover, compose, and invoke services for humans with semantic descriptions of their functionality. And this brings me to the work which was what the SPISA award is about. At that point, as part of the Demolists coalition, I worked on Demolists, which later became Owls. And it was a service description language to do exactly what I mentioned, automatically discover and compose available services to accomplish user tasks. And this described services in 3 different ways. It would, there was a profile, which was an API that described the expected input and output of the service, also some preconditions, postconditions to enable planning. There was also a grounding that would describe how that service would be invoked, and a process model that, especially for complex services, could describe intermediate steps. So for example, this would be useful when the service would be expected to require additional information during its execution. It's useful for the agent to know that in advance. And below you see also a picture of the Owls profile ontology, and you can see it's fairly rich and expressive. And looking back now at this work, and partly here for this talk, it's clear that this work didn't really take off to the scale that we imagined, except for some relatively limited success, I think, in business process modeling and such areas. And I think it's because perhaps the real world need wasn't really there. In retrospect, it feels like, we were building this very expressive, very, very capable ontology. And there was a belief that if we define this, people will use it to describe services, and there will be agents that will do this flexible dynamic composition. But that just didn't come about. And that's partly because I think the usage scenarios were not well defined. It wasn't clear who these agents were, who they were working, who would kind of build them, and how they would access these services, and just specific use cases were missing. I think we also underestimated, again, in retrospect, just how hard it is to define the semantics of functionality in a context and usage independent manner. And I know this is something that again, Ora Lucilla had also referenced in his talk. And so it turned out that this approach, again, fairly complex, but was actually only suitable for fairly simple and well understood services. For anything more complex, the ontology was hard to use, it was verbose and ambiguous. And the assumption that this kind of flexible composition could be done without humans in the loop, that were reviewing the compatibility of the services, the privacy, which is now a big thing these days, of the data that's being passed around, and generally reviewing the quality of the services being composed, it feels pretty unrealistic in retrospect. And I think these are sort of, it's, of course, it's great to have 2020 vision in hindsight, but I think fundamentally the problem was that the aim was too broad in a domain that was poorly structured. So it wasn't clear what the best path is to building capable, trustworthy agents. It wasn't clear what kinds of services we'd want them to be using. And in such a situation, it's actually probably better to have iteration happen, lots of trial and error and real world evaluation before settling on standardizing a specific approach. And that maybe was something that, I think could have would, in retrospect, I think that would be sort of the easiest sort of lesson forward, is that don't rush to standardize. So anyway, since that time, I decided to go deeper into what it meant to support human work. I mean, partly realizing that human work is complex and building agents to support them is not necessarily realistic unless you really understand what they're working on. I moved to the industry and started kind of caring a lot about information workflows, about knowledge professionals and what they do. So this brings me to the next section of my talk. So who are knowledge professionals and why should one care about them? So these are really a very broad range, broad group of people who create and consume knowledge and information in various forms. Most of us listening to this talk are likely knowledge professionals. We perform high value creative work with non-routine problem solving. We're typically coming up with new ideas, solutions, products, strategies for specific business, research, or societal outcomes. And essentially, we're working again in these sort of poorly structured domains with many possible non-obvious solutions. And we have to constantly make decisions on what to focus on, which directions to pursue, which potential opportunities that exist to capitalize on. And these decisions are guided by information, almost all of them. And so information is critical to decision-making and to the work of knowledge professionals. But we also see that in high-stake business settings such as finance, such professionals tend to work in pretty demanding contexts. They have a lot of time pressure and also what I tend to think of as information pressure, which means that there's a lot of information around, but there's little time to either sort of connect it to their work or to identify sort of what would be relevant information and to go look for it. And this is where I think that intelligence support that goes beyond existing tools such as enterprise search and knowledge management could be really valuable for this category of people. And in essence, I think these professionals need, you could say, their own version of the original semantic web vision. So they need, I think, an intelligent platform that can support them in their work, that works on their behalf, with a few key differences. The platform should understand user priorities or work by observation, and possibly with access to their professional work data, and understand the significance of their work in the organization and the real world context in which they operate. So basically, the system should understand the user without necessarily having the user specify everything or invoke an agent. And by understanding professional goals and workflow, the platform should be able to respond with timely, proactive support. And specifically for information workflows, we're talking about informational resources. So it needs to understand what the value of specific information or other types of informational resources are for a user so that it can search constantly for relevant resources in organizational repositories in the web and bring them to the user's attention in a timely and natural manner. And finally, it needs to know, of course, when these priorities change, because these user work directions are constantly changing, and you don't want to be going back and specifying changes to your profile, so on. And why would might an intelligence support platform like this for professionals work now, when the earlier semantic web vision, for example, with agents didn't really pan out? I think that now many of the building blocks for this vision are actually here, and partly as a result of the COVID lockdown. So in the last 2 decades, work, and especially knowledge work, has been going through a digital transformation that has accelerated immensely due to the COVID lockdown. So with the push initially towards remote work and now towards hybrid work for all of us is getting increasingly distributed. It's performed across geographies and time zones, and it's hence mediated by technology. And Microsoft enables well-structured user work data, so emails, calendar files, chats, and the like, to be exposed via the Graph API, the Microsoft Graph API. This means that platforms like ours can now access digital traces of user work on behalf of the user and try to make sense of it. Another is side effect of the lockdown. that is, I think of as a building block, is that in order to stay connected with colleagues, enterprise chat environments such as Microsoft Teams and Slack have really taken off. And these environments have bot integrations that enable information to be delivered to their users in a unified work environment, just like a colleague reaching out to them, and they work on mobile devices. This means that we can now deliver information proactively to users in a relatively natural way, regardless of where they are. And finally, 2 decades means that the AI and machine learning is increasingly sophisticated. So recommendation systems are now ubiquitous and commonplace. I'd say that, and well understood, the Netflix prize was in fact announced just a few years after the paper, the Scientific American paper came out. And that led to a proliferation of recommendation systems such that there are just now a huge range of available methods, and people understand recommendation systems, both as consumers and as developers. And most recently, it's hard to talk about AI without talking about large language models. The advent of large language models have really to interpret unstructured language and data have been really revolutionary and have shown sort of really impressive capability again. And again, that's very relevant to kind of user work because a lot of it is unstructured language. So the world has changed, I think, significantly in the last 2 decades. And I think that this vision of intelligent support for humans is now much more plausible. And so much so that at ModuleQ, we're starting to work on it. We're starting with a very small slice of users. So we're focused essentially on B2B customer-facing professionals whose work is driven by sort of sales targets. So these are companies that are defined in CRM systems such as Salesforce. And their work is communication heavy, which means it's easier to trace their workflow from their communication traces. They leave a lot of traces as they talk to clients, as they participate in meetings, as they access systems inside their organization. And these users are extremely valuable to their businesses because they bring in revenue. So we've developed a method, a data fusion method, some data fusion algorithms, we call it personal data fusion, to pull together a user's work traces from various systems of record, and primarily Office 365 and Salesforce, and use them to identify a professional's business priorities. So here in Teams, you can see our bot is showing a card representing an interest that it has just found, a company that it's located in the user's inbox data, and asking if this is actually a priority. So we can surface these for sort of human in the loop confirmation. And for customer-facing professionals, as I mentioned, these priorities are primarily companies, so clients and partners they're working with. They can also be people and sometimes sectors. And then these priorities that we identify are used to drive proactive recommendations of news, organizational internal research, and breaking news to users as daily updates, the daily news updates delivered actually twice a day, or driven by professional workflow, such as just before meetings, or triggered by some change in status in CRM. If a company goes from prior to tier 1 to tier 2, or there's a change in their subscription, these would all be things that could that could trigger a change and cause information, relevant information to be delivered to the user. And these our recommendations are sent in small digestible chunks. We only send about 4 articles for a news update. So, and that's because we know that user time is kind of, and attention is limited. So we're aiming to deliver only really very high relevance information. And for the same reason, kind of work in a warm start manner. So we really want to understand as much as possible about users before we make recommendations, so that the recommendations are as relevant as possible. And to go into a little bit more detail or talk about a few more aspects of our approach, basically user work data, it sounds like, yes, this should be possible in theory, but in practice, as you can imagine, it's incredibly noisy. Email is very noisy. Even CRM content, which appears as kind of, represents the set of targets that a salesperson needs to pursue, often ends up reflecting sort of the organizational view of what a user should be working on, or a professional, and not necessarily the professional's own perspective. So we need to sort of understand that all of these sources are noisy, and we really need to triangulate information from multiple sources to identify meaningful signal. So for example, if we see that a professional is interacting with a company and having meetings with them, and that company is also a target account for them in CRM, then we can infer that this is actually a professionally meaningful interaction. Secondly, we assume that content relevance is primarily driven by whether the content is about relevant entities or concepts. Now, of course, there will always be personal preferences about content style and whether certain kinds of content are more relevant and useful to certain users or not. And we do learn these too. But we consider this as a secondary refinement to content relevance. So this means that we're using essentially content-based filtering recommendation methods, again, for the reasons I talked about earlier, mitigating cold start, so on. The third aspect is, perhaps this is sort of a corollary of some of the Alice work, is that we're following a very iterative and grounded approach to kind of building this platform. So we're starting with very much the simplest workable solution that functions in the market and solves a real world need. And then we look to sort of progressively refine it and increase the granularity of what we can capture about user work, about different types of roles and domains that we can support. And this is really important because we want this, there is really nothing like this out there. So it's important that we get early validation and we can refine based on user feedback so that we build something that users actually care about and want. A fourth aspect is that user work data is inherently sensitive, especially for those in customer-facing roles. So our initial market focus is actually on financial services, which deals with highly sensitive data and is also highly regulated. So we need an approach to ensure that organization and user data, client data is treated confidentially and kept separate. And so essentially this implies a sort of a distributed structure, but where possible, we do centralize non-sensitive data, content and processing. And finally, we aim to build human-centered AI. I think that's maybe clear with the previous kind of discussion. And what this means is that we reflect the system model of the user back to the user. So in the screenshot on the right, in the background, you see the user profile is being shown to the user, and we show kind of which organizations we've detected in their work traces, which topics we know that they're interested in. And we also aim to show why recommendations were made. So if there's a recommendation, we describe what it's related to, what are the entities and themes and concepts that the user is interested in that these are related to. And we also allow users to give us feedback on why a recommendation was not useful. And we find that this really matters. So the more high stakes, the more high regulated and sensitive the domain, and the more demanding the user, they really want to understand why a recommendation was made. And they don't have patience for things that are either don't seem relevant at first glance, or they're not able to understand what that's about. So we find that ends up being very important. So I've talked about some of the building blocks of our solution, of a solution in our approach. And despite all this, this really still is a very challenging problem. And what makes it challenging to my mind are really two kinds of challenges. One is that mastering context is still very hard. And what I mean by this is that context would allow us to align entities between user work data and business content. And without that, it becomes very hard because the references are ambiguous. Users may use acronyms, or they might use misspellings or different names. Business content has, or content in general, news content has the same problem. And so bridging across this is non-trivial. It's also hard to identify sort of hidden connections between entities. So for example, if an entity that a content is about is a competitor of the client of the user, this article is likely to be useful because it's about a competitor of their client. And if we can identify that, then we can again increase the chances that we detect such sort of relevant content. And finally, content can help reduce noise. So we see this often that in, for example, in the data extraction, we might find in an email, for example, 3 different companies. But if only one of them, again, is in the user's CRM and the others are not connected in any obvious manner to the user or their other interests, then it's quite likely that the other 2 are noise and only the one that shows up in CRM is actually the key one. But again, we need sort of this context. And I think another example is when we have content, which is about Microsoft, but if you don't see any other products of Microsoft mentioned, or we don't see any executives, or the article is not about the technology sector specifically, it's very likely that this Microsoft it's not a good article about Microsoft, or it's a sort of a peripheral reference. It's not really a relevant content. So I think context is really a key problem, and that's something that we're constantly trying to identify and to use. And a second problem is lack of access to data. So this is, again, as I mentioned, much of the user data is sensitive and confidential, but this also means that it's hard to acquire and learn from. That means that we don't have training data, for example, of professional work, of professional users that we could, or reams of training data for sure we don't have, that we could use to develop recommendation algorithms or priority identification techniques. And because I'm often asked, well, now we have LLMs, aren't these challenges solved? And no, they're not, because LLMs face pretty much the same challenges. They don't have access to context, and they are also not trained on representative content. So although they're pretty useful for understanding what external news content may be about and a general sort of research, they're not very useful for user work data. And so this brings me to how we use knowledge graphs specifically to address the challenge of context at ModuleQ. And I'll go now to move over to talking about our architecture and the way the knowledge service functions within our context. So this here is a schematic of the ModuleQ platform and architecture. So on the left-hand side, you see in the deep blue or bright blue boxes, external data that's pulled into the system. So we have work data about users. So as I mentioned, email, calendar, also CRM accounts and opportunities. That's pulled into what we call our profile service that uses this personal data fusion to triangulate across various multiple sort of sources and generate user profiles. We also pull in real world knowledge, and this is pulled in through Refinitiv, which has many content feeds for business content. And in fact, I think from what I've seen, they have one of the largest knowledge graphs or feeds around companies in the world, and they cover really a global range of companies. And Wikidata as well, to some extent, because no matter how good Refinitiv is, there are still gaps, of course, in its coverage, and Wikidata is sometimes helpful to fill in the gaps. That's ingested by our knowledge service, and I'll talk about that in more detail in the next slide. We also ingest a fair amount of content. This is business news and internal, so organization-specific insights. We have some 300 plus publishers. We have Refinitiv, which has breaking news alerts, so content that's kind of part of that. There is also, I think we have a SharePoint integration as well. All of that kind of provides content that we then need to annotate and this is done via the use of a couple of third-party services as well as our own tagging and NER. So we make use of Spacey and Refinitiv, which also provides an intelligent tagging platform. And this one is, again, Refinitiv is really focused on business content. So they both have a repository of entities and content, but they also have some tagging services that allow you to bridge and kind of reconcile with these real world entities. And so this annotation service then kind of builds tags, annotates the content with tags, and essentially builds a content profile. All of that flows into the recommendation service that then actually creates these personalized content recommendations for specific use cases, and that's shown on the right. So we have the news updates that I talked about earlier. We also have pre-meeting briefings. So these are briefings for specific meetings that the client is going to have, important, key client meetings, so not for all meetings, and sent an hour before their actual meeting. As you can see here, the knowledge services really sits at the center. It's sort of, I'll talk about exactly how it functions. It's essentially providing context to the profile service, to the annotation service, and enabling and helping determine content relevance. So there are also captions in green. You'll notice there's customer and central. This is indicating where the services are run. So essentially all of these within the ModuleQ platform, these components are microservices that are run inside our customer tenant. That means that if we are working for, if ModuleQ is a platform that's operating inside an organization, we actually run our entire platform, or this part of it runs inside their customer tenants. It's inside their firewall, and hence their data actually never leaves their firewall, it stays inside. But there are some components, namely the knowledge ingestion and the content ingestion, that are also run in a central environment so that we can collect and process public content without having to do that multiple times. And that data is then synced down to their counterparts in the customer tenant. So let's dig a little bit deeper and drill down into the knowledge service. So as I described, on the left, you see a schematic of a real-world knowledge being pulled into our central knowledge service that includes essentially information about public and private companies, domains, names, aliases, descriptions, also products, people, sectors, topics, and all that is synced down to another instantiation of the knowledge service that sits in the customer tenant. And that ingests essentially customer relevant entities and topics. Just to give you an idea of the size of the knowledge service, it's about 2.7 million organizations, around 2 million topics, and we pull this together from a number of different sources. And here I've listed features that, again, this is a distributed knowledge service. As I mentioned, we are doing this in a very iterative approach. So we start with a limited set of entities and concepts of interest. And it's we do have these entities are typed and we have relations, but it's really built for sort of fast search. So there's no formal ontology that we've defined, and there is no path-based queries or reasoning that we're using yet. I think we're on the brink of doing so. But certainly at this moment, it's really more serving as a universe of entities and topics for the rest of the system. And as I'm described, it's kind of, we're pulling in, ingesting data from multiple providers in the feed, and we're locally merging it. So there is potentially conflicting information that does come, and we have to make decisions about sort of what we use. And we have some heuristics to do that. At the same time, we track the provenance of where we got each piece of information from so that we can, sort of track down in case of problems, but we can also, in case a particular source becomes unavailable because we are a company and maybe the source is now, the license runs out or what have you, we are still able to sort of purge and kind of surgically remove that part from the knowledge graph or the knowledge service and then rebuild the rest. We also have versioning and usage tracking. Again, that usage tracking is to ensure that we have things that are useful and hopefully relatively little things that are not useful. The data is refreshed periodically from the source feeds, and this is primarily true for Refinitiv data feeds. I think about weekly we have all the data is refreshed. And it's also designed, the service, as I mentioned earlier, for the provenance example, is really designed to be built from scratch from the source data if need be, and while keeping the identifiers stable. And that's, kind of complex of its a complex problem in its own right, but that was kind of that we've sort of done that for companies for sure. And as you can see now, we see that there's a central knowledge service that's foundational, and of course proprietary metadata stays in the client and just builds on top of what's already available. And if we look at sort of some of the challenges we face, and I'm sure these are very familiar to many of you, it's of course problems of data quality. So there are inconsistencies in the way companies are referred to. Sometimes the data is just not fresh anymore. So a company we think it's still an active company, but it's really not there. It's kind of closed down, or it's been merged with another company. There's lack of coverage, and just ensuring that the data is correct. And it's hard, to be honest, to even know if the data quality, how bad the data quality is, because of course we have to have human kind of reviewing that. And so we do show, by exposing some of this to users as part of our tool, I think some of this data does get reflected back and corrected. But there are portions where we have to sort of go in and try to fix data quality issues and to look for problems rather than finding them. And so it's not necessarily a systematic approach. There's also the problem of entity mapping and equivalence. So we have customers, for example, customer knowledge services may have certain companies in them that we also know through our central knowledge service, and then identifying that this is the same company, even though they're mentioned differently because maybe they have the same people or as directors or something. But that's certainly something that we also have is a challenge for us. I also already mentioned the problem of company churn. So companies are not stable entities. And in fact, when you work on this, you realize how frequently changes are happening all the time in the business space. So companies, their people are changing, they're merging, they're closing down, when they merge, their sort of region can change because now they're owned by a multinational that has headquarters in another region. And there's just a lot of information about companies that's constantly changing. And handling that is something that is also a problem. So because we have certain companies that are there in user profiles because they care about them, those things we sort of quickly identify problems about, and we sort of fix data issues when we see it. But there are other parts of our knowledge service, again, where we cannot solve a problem until we see that. Yet another problem is topic proliferation. So it's not clear here, but many of these topics are coming from our content. So the Refinitiv intelligent tagging annotates content and identifies topics and terms that we then use to allow users to express kind of their interest in certain topics like cloud computing or Bitcoin. And what we are seeing is that we have a lot of topics, and it's hard to know which ones are useful for which types of users, and to I think what's been called representational granularity, to manage that. So how do you distinguish between something that's a topic and something that's really just a key phrase that happens to be mentioned but is not, it really falls under the topic? And again, this is, I know, a big area all by itself. Finally, we also see this problem represented in kind of our topics and entities for roles. So we see that different roles within a company can sometimes have subtly different topics that are very similar, but the focus is just different because of their roles. And again, we currently keep them all separate, but ideally we'd be able to sort of connect them and say that these are really related topics, and managing that is a challenge for us. So that was kind of about the knowledge service as it's built. Now looking at kind of how it's being used, I think I've already referred to various parts of them, but I'll sort of go through it quickly here, is that we are using the knowledge service to provide context, so provide a universe of relevant linked entities and topics to the profile service and to the annotation service that allows us to detect whether the content is coherent, whether it aligns with professional interests, and to reduce noise. In terms of relevance, maybe I've talked a bit less about this. I think the knowledge service can kind of help us determine content relevance based on entity types that are salient. So for example, companies are particularly important to our user population, much more so than topics. So if an article is about a company and has topics they care about, then it's particularly relevant. But if it's only topics, then it's not as relevant. So the entity type makes a difference. And so, having the knowledge service tell us what type it is, again, that is useful. There's also the potential to use pods. So for example, if there's a major product launch by a competitor of a client, again, that's really useful to know. Now, we don't actually use this yet, but I think we're exploring how to do this. And we know that we are going to have to do this for our clients. A third aspect, how the knowledge service helps determine relevance, is really by kind of modeling this sort of role-dependent topic. So a sector banker has different things they care about than relationship managers. They also care about different types of news. So sector banker is someone who cares about an entire industry and wants to know about trends in that industry, whereas a relationship manager is going to care about their relationship and maybe and how their target account is doing, what the competitors of that account are doing, and so on. And I already mentioned that it enables kind of explanation with familiar entities. So this brings me, I think, pretty much to the end of my description of how we're using knowledge graphs to support information workflows. We have a lot of future work that is unsurprisingly based on, can we use large language models as far as possible to guide, like using generative AI to guide entity extraction, content relevance. Also looking at, can we learn to rank, keeping in mind that certain types of entities and content are more useful. Use LLMs to identify semantic connections between topics using embeddings. And also we have, at some future point, I think, using graph-based embeddings for entity and content similarity. Another near-term future work is handling multilingual content. We know that many of our users are actually based in not just in the US, but also in Europe or in Japan, and they need to be able to cover, and they also cover different regions of the world. So handling multilingual content is very important. And we expect that along with this, we'll also have to deal with, again, that concepts, slightly different concepts. I don't think that the same concept is going to be translated in exactly the same way to another concept, another language. And further on into the future, I think we, of course, want to build more accurate and richer user profiles, better understand information relevance, and try to generalize to as many roles and industries as possible. So with this, I think this brings me to my last slide. Essentially, I talked about, how knowledge professionals need AI augmentation, and that crucial building blocks to understanding and augmenting their workflows already exist. I described how we consider knowledge graphs to be key to providing context, explainability, and to determining content relevance. And I hope that maybe I also managed to present a case that professional information workflows, I think, are a very rich and meaningful application area for knowledge graphs. And there are a few distinct kind of characteristics of these workflows. One is this distinction between private, public, organization-specific knowledge, and this distributed architecture due to these confidentiality and privacy concerns. So with that, I want to thank you for your time. And if you found, and I'm looking forward to questions that you may have. And if you found this talk interesting and would like to learn more, please feel free to reach out to me either on LinkedIn or via the email given on the slide. And before closing, I'd also like to mention that the work I presented today was done in close collaboration. So the work at ModuleQ was done in close collaboration with David Brunner, who's the founder of ModuleQ, and a team of very talented engineers and product folks. So we're always hoping to find people who are also interested in this problem and to work together. So with that, thank you and look forward to hearing any questions.
Good. So thanks, Anupriya, for that very interesting talk. Maybe a short round of applause.
Thank you.
There are some questions on the chat. Towards the end, you have also touched on that a little when you talked about that, about private information and so on. And there were some recent proposals about how to model data usage policies and licenses and vocabularies for data privacy. Did you come across them? Did they look useful? Or what is your stance towards them? Would they help in your overall architecture?
Yeah, I think I have certainly not come across them, and I would like very much to go and read up about that. So I think certainly that would be very helpful because we are, I think in as much as there are existing kind of best practices or patterns that we could reuse, I think that would be great. I think there's, I think data usage, I must also say though that this is again one of those cases where a lot of this negotiation around usage of data and what can be shared, what can't be shared, really happens in meetings where people get together and say yes and no, and it has to pass through a committee. And so I think while it's useful to have ways to express that, we also always have to be mindful that it's actually still going to be decided by a bunch of people sitting in a room and kind of making the decision about whether, because again, it's the organizations have to give access to this. And so they are the ones who are feeling somewhat defensive naturally.
Yeah, but I mean, then the decision could be like written down in a way that is processable in a way.
Yeah.
Maybe we don't need the slides at the moment. So
yeah, let me stop sharing.
So
Nice.
There was another question when you talked about that you ingested like Wikidata and knowledge graph style sources. One question is if everything, like there were some advantages in knowledge graph construction, like how to get knowledge graphs from databases, from text, and so on. If we gave you a knowledge graph of all your domain knowledge, would that make your life easier or harder?
Oh, that is one of those double-edged swords, I'm sure. So I think yes, we need as much data, as much relevant context, and I think the keyword is relevant context as possible. But at the same time, it is easily possible that we just have so many entities that we get kind of bogged down in topics and in information that's not directly usable. So I think for us, that's why we sort of been, again, building this knowledge service very iteratively. And so I think while it would be great to have a knowledge graph that has clean data, that's always up to date and accurate, and we would certainly use that, we wouldn't use all of it. Probably we'll pull up from it for what our users need. Okay. And I think there's also just like, given what I see about the way roles, different types of people think about topics and the entities, I think we really will end up needing sort of these different spaces of the knowledge graph. So even though there is a knowledge graph, maybe that's a single, somehow consolidated representation, I think in actual application, it will end up getting changed and getting kind of customized to sort of more usage views.
So talking about customization and data sources again, you ingest Wikidata and some high quality data sources, but do you employ some curation, or human curation, especially on top of them, or do you manage in a fully automated pipeline there?
So I think we strive for a fully automated pipeline. What this means in practice is that initially, when we're pulling in data, there is a high level of human curation in ensuring that the data is the kind that we want and it's representative of the entities. For the entities and things we care about, it's actually complete in its fields and properties and so on. Once that's done, we try to define some sort of mapping so that we can actually then do this automatically. Nevertheless, I think we have, I think one of the sort of maybe gaps we have is in monitoring when data quality changes, or if there's, because again, we're pulling this from an external source. What if there's a problem on their end? We unknowingly pull this in and it sort of corrupts our database. But again, this is why we want to be able to refresh and rebuild the graph in case there's a problem and it does get fixed within a day or so, or within a week or so at the source end, we're able to then quickly reheal our graph.
And if you sometimes have the feeling that there's something wrong and you need to fix something, do you sometimes also have the urge to like fix it at the source, which would be possible in Wikidata, for instance? So this address, if it were correct on Wikidata,
yes,
we wouldn't need, we could save like 3 levels of 3 steps in the pipeline.
Yes, I think that would certainly be possible. I would say that it's not necessarily easy to update things on Wikidata for engineers who don't already know how it works. I think I've had our engineers kind of try to pull data from Wikidata, and again, not being knowledge engineers, it's a little bit complex, but I think it's certainly possible for the entities that we have that we update that information. And I think the limiting factor, if I may say, has been more that for a few types of entities, we've gotten that from Wikidata, but we've also found that for the vast majority of the entities that our users care about, the Wikidata has holes. And of course, we're not able to fix that by using another source. So we have to really come up with that information ourselves in order to do that. And again, that's certainly some kind of investment of time and resources cost.
Okay. Maybe here's another one. So when you are in a company and you say sometimes you're addressing like people more on the relationships and sometimes key account for a sector, do you also come across organizational boundaries within a company, like between departments and the likes, or are you just targeting one heterogeneous group per company?
Yeah, that's a great question. So at this moment, we're targeting companies as a single whole, but we do have the case where there are different departments of companies, and certainly when users are in, when our sales professionals, for example, are talking to a company, they're probably talking to people within a specific department, and they may not be, and I think that's something that we don't explicitly capture. So we may try to capture the topics, and we capture the people, but we don't, of course, know about departments within external companies, unless that's reflected in the CRM somehow. Sometimes it is, and then we can kind of make use of it.
Talking about some technical aspects, maybe you worked on like service descriptions and so on, and you have plenty of sources, and you tap Office 365 and so on. What is the role of, like, do you see why hasn't the world applied service descriptions and we would have an easier life, or how do you see the state of the art in reality there when it comes to these kinds of description of things that you tap and how you could benefit from that.
Yeah, I think that yes, so we make use of a lot of services, and I think it's really hard to think about how you would mark these up in a way that you would say, oh, I can take a totally hands-off approach to these kind of things being pulled in, because again, even though you can mark up the semantics, that, like, for example, even getting it from the Microsoft Graph, we need to understand what kinds of fields, how we're going to use them further on into our system. And like the title or the subject or the attendee list or what have you. And I think those are, you could potentially describe those, but I think it's hard. There's a lot more. I think you'd have to spend a lot more effort in kind of building this very this description that kind of matches both your internal, conceptualization of the data that you're working with, as well as the external one. And it may not, and then if the service changes, it might be really hard again, because you may not be able to deal with that service change because you're not ready for it. So I think that it's still really a ways out. I don't see that this is something that's realistic, except in fairly limited scenarios. I can imagine, for example, in home automation or in certain places that these things do work, again, because they're relatively simple services and it's within a constrained domain. But for something like ours, which is a much more open world and general knowledge, I think it's really hard.
Okay. Next question. There was, when looking at all these logos there was some Elasticsearch as a storage backend. What are you missing from semantic web tooling that would fit your requirements, or where would you say here's a gap and we cannot work without that? People in the community are proud of what they built, right?
Yes, I know. I must have was a bit embarrassed as I was putting in MongoDB and Elasticsearch, but I think the reason again is because of this sort of iterative approach that we are using. So I think so far, as you see, we're mostly using our knowledge service as an index for things, and we just need a fast search on that. And much of our other data is also in Mongo, so it seems natural to use this for representing entities. And I think that's just, it's a lot of times. There's also, when we're working again in this sort of real world context, there are performance considerations that come into using a tool. And with MongoDB, we sort of understand those performance considerations very well. In fact, the first question we have when we say, okay, let's use a new tool is, okay, can it of course do the kinds of, does it have the technical capabilities? But then the second question almost immediately is, can it scale? Can it perform? Can it give us the right latency and so on? And how much virtual memory is it going to require? So I think since MongoDB is very well understood, it's kind of harder to move out. That said, like I mentioned, we are seeing that we want to represent relations so that we can have path-based queries. And that is a limitation we're running into right now as to how do we do this easily on the infrastructure we have. And I don't think we can. So I think we are going to have to look for a different solution. But again, that involves, it's an engineering effort. I think a lot of this is about the engineering effort involved. And we're a small startup working very iteratively. So it's not something we invest in easily.
One question, so you talked about that you're doing a lot of engineering. How much knowledge work is like involved in that whole thing? So do you have dedicated people who only curate the knowledge base, or is it technical engineering driven more?
I think it's all technical engineering. So to give you a sense of our company, we're about 30 people altogether. And we have a team of maybe 10 engineers, a couple of data scientists, the rest of it are sales and product people. So we actually don't have anyone dedicated to working on knowledge. And even though it is a crucial part of our system. So I think it's possible that as we grow, we will be looking to get more knowledge engineers and to helping sort of build out the knowledge service and curate knowledge. But I think at this stage, again, it's like the iterative approach. So I think we're the engineering ability to sort of run this at scale for, I think you saw that we're running this for London Stock Exchange, which is a partner and a client, and running it for other banks. That just requires a lot of engineering kind of muscle capabilities. That's where we've invested in this moment.
All right. So coming towards the end, last question from the next speaker, Terry Payne.
Hey, hi, Terry.
So he wants to know, given all these services that you have, how would you contrast the need to model on the one hand the interface, or on the other hand the knowledge that is being exchanged? And did you get the right trade-off with OLS?
I think, well, with OLS, I think we focused very much on the interface and what the process kind of descriptions and steps, and maybe not so much on the kind of what kinds of data is it sharing. And of course, that was when the OWL ontology was still being developed. But I think we were missing that real world description of kind of what data do we want to put together, exchange, and so on. I think for us right now also, I think it's so actually the question was for current usage, what is the distinction between service specification versus specification of the semantics of the data that's being exchanged, right? I think for us right now, it's the case that it's really about the data. It's really about the knowledge, the entities, I think, that are there. And the service, again, is something that we can have a human sit there and program it. And if it would be nice to be able to detect changes in the services automatically, but beyond that, we still need that human in the loop for the service integration. But the data thing, I think, is something that is, in fact, a bigger problem, because that has impact over a much larger space of our system. And so I think, to me, at least, it would be more in that region.
All right. Then thanks for all the insights, and thanks for answering all these questions. So a virtual round of applause again to Anupriya. And then I do some housekeeping announcing the next talk. So here we have the next talk will be by Terry Payne. Autonomy, the Web and Semantic Web Services on the 4th of October. See the website, follow us on X Twitter, find old recordings on our YouTube channel. And as an academic, I would say cite and subscribe